All right, so we have this function, c of t, and what it does is first it's a parametric equation. It says pair of parametric equations that describe the trajectory of a particle at time t, and we're asked to find the minimum speed. Okay, so to find the minimum speed, there's two pieces to this. We first have to find the speed, and then we've got to minimize the speed. So let's begin with finding the speed. And as you know in the book, when you read the section on parametric equations, to figure out the speed, you got to first figure out the arc length, right? And this we figure out by computing the integral, in this case 0 to t of derivative of the x component squared plus the derivative of the y component squared, and then you take the square root of that whole thing, and that's what you would integrate to figure out the arc length. Well, to do the speed, we would and I'll call speed v of t. We would take the derivative of the arc length. Okay, so what we're doing ultimately is we're taking the derivative of this integral, and the fundamental theorem of calculus says they undo each other, right? So these two things basically undo each other. All right, let me go ahead and I'm going to copy all this here. Alrighty, scooch it over. All right, so what I'm saying is a lot of things get taken care of here when we're computing the speed, because when you're taking the derivative of the integral, you don't actually have to integrate, okay? You end up getting just the integrand with the t plugged in. Okay, so the speed ends up being square root x prime squared plus y prime squared. Okay, so in our particular problem, here's our x and here's our y. We're going to go ahead and plug those in, taking derivatives, squaring, and all that. So when you do this, and let me go ahead and scooch that up if I can. Okay, so x is 2t cubed minus 8t. So its derivative is 3t squared, I think I need to make this bigger a little bit, minus 8. Okay, so that's x prime. Y prime is, scooch that, t squared plus 1. So we end up getting 2t for y prime. That needs to be squared. All right, so this is v of t for our particular function. And I think the book says, why don't you go ahead, square the speed, and take the minimum of that function. So the square of the speed would end up being just 3t squared minus 8, all of that squared, plus 4t squared. And if you expand this piece right here, you end up with, 9t to the 4th, and then minus 24 times 2 is 48. So minus 44, that's right, t squared plus 64. So this, let me scooch that out, is v squared, the speed squared. And we're going to go ahead and now minimize this function right here. Okay, so part 2, okay, so this is part 1, is we've got this function, we've computed, this is the speed, this is the speed function, well, the speed squared, but this is the function, right? And the hint was we want to minimize this now. I'm going to go to the next page and do that. All right. So now this is part 2, minimizing. Okie dokie. We want to minimize, what I said was v squared. Oops. V squared, which is 9t to the 4th minus 44t squared plus 64. How do we minimize? Well, we got to go back to Calc 1 and remember that what we got to do is take a derivative, set it equal to 0, and then you get these critical points. And then those critical points will tell you where you have maxes and mins. Okay. So if we compute the derivative of v squared, well, that's a simple derivative. It's 36t cubed minus 88t. And if we set that equal to 0, all right, pull out the t, we get 36t squared minus 88. And so we end up getting t equals 0, and t squared equals 88 over 36, which simplifies to 22 over 9. Okay, so t itself then must be the square root of that. And we want to take the positive square root since t has to be bigger than or equal to 0, right? So this is a critical point. And so we end up plugging it back into v squared of 22 over 9. And when you do that, I think I did this over in Desmos earlier. Let me go ahead and pull that up. Here. And you get 92 over 9. Okay, so you end up getting 92 over 9. So that is the min speed squared. So the min speed has to be square root of that. Alrighty.